All right, strap in, everyone, because today we are taking a deep dive into, well, something kind of mind-blowing, sonoluminescence.
Yeah, yeah,
Where sound waves create light.
yeah.
You sent in some fascinating factoids about it, and I've got to say, I'm really excited to unpack this with you.
Yeah, it definitely sparks the imagination. I mean, we're so used to light coming from, the sun or a light bulb or, a firefly.
Right.
But from sound waves, that's really something else.
That is wild. And that's exactly what your first factoid captures, sonoluminescence,
Mm.
a light from imploding bubbles in a liquid.
Right.
So before we get into the how, can you just kind of paint a picture for us? Like, what are we talking about here?
So imagine like a glass of water,
Okay.
seemingly ordinary, right? Now imagine introducing sound waves into that water,
Okay.
maybe from a speaker or even just tapping the glass.
Okay.
Those sound waves cause these like tiny little bubbles to form and grow.
Okay.
And here's the kicker. When those bubbles collapse, they release this like burst of energy in the form of light.
Oh,
Like a miniature fireworks display
wow.
happening right there in your glass.
Okay, that's already blowing my mind. But, like, how on earth do sound waves even create light? That just seems so counterintuitive.
Right.
Yeah.
Well, it all comes down to, and this is your second factoid, acoustic cavitation.
Okay.
So those sound waves that you mentioned create these areas of high and low pressure in the water.
Okay.
And during the low pressure phase, the dissolved gases in the water come out of solution.
Okay.
They form these tiny bubbles.
And it's like those gases are just kind of waiting for an opportunity to escape.
Exactly.
And the sound waves give them that chance.
Precisely.
Got it.
And then when that high pressure phase hits, those bubbles are squeezed with incredible force, causing them to implode.
Oh, wow.
And that implosion releases a tremendous amount of energy, some of which is converted into light.
So it's not the sound itself that's making the light. It's the energy released from these imploding bubbles.
Exactly.
That's so fascinating. And it makes me think about your third factoid. Extreme temperatures. Bubble collapse generates brief, intense heat. So how hot are we talking?
Hold on to your hats, because we're not talking about a warm summer day here.
Okay.
These collapsing bubbles can reach temperatures of thousands of degrees Kelvin.
Thousands.
Even hotter than the surface of some stars.
Wait. Hotter than the surface of the sun
Mm-hmm.
in a tiny little bubble.
It's pretty incredible, right?
That's insane.
And it highlights a point that I think is often overlooked. We tend to think of stars as these, massive distant objects.
Right.
But here on a microscopic scale, we're seeing similar levels of energy being generated.
Yeah.
It really challenges our perceptions of where heat and light can come from.
Absolutely. It's like those bubbles are like tiny fleeting stars, which of course brings us to your fourth factoid, that mini-stars analogy. It's such a vivid image, and it really captures the energy contained in these imploding bubbles.
It does, to reach those temperatures, the energy within the bubble has to be concentrated to like an almost unimaginable degree.
Wow.
It's like squeezing all the heat from a bonfire
Yeah.
into a space smaller than a pinhead.
Geez. Okay, so we got sound waves creating bubbles, bubbles collapsing and releasing intense heat and light. But here's where things get really interesting and a bit speculative. Your fifth factoid talks about the fusion potential of sonoluminescence. Now, I know fusion is the process that powers the sun, and it's something scientists have been trying to replicate here on Earth for decades because of its potential as a clean energy source. Are you telling me these tiny bubbles could hold the key to fusion?
That's the million-dollar question, isn't it?
Yeah.
And it's precisely what has scientists so intrigued by sonoluminescence. The extreme temperatures generated during bubble collapse have led some to theorize that it might be possible to trigger nuclear fusion within those bubbles.
So theoretically, we could have miniature suns popping in and out of existence in a glass of water. That sounds like something straight out of science fiction.
It does, doesn't it? But that's what makes this field so exciting. It's pushing the boundaries of what we thought was possible. However, and it's important to emphasize this, the idea of using sonoluminescence for fusion is still highly debated within the scientific community.
So there's a lot of excitement, but also a healthy dose of skepticism.
Exactly. There are significant challenges to overcome, both in terms of understanding the complexities of sonoluminescence itself and in developing the technology to harness it in a controlled and practical way.
Okay, so it's not quite time to dick our power grids and switch to bubble-powered fusion reactors just yet.
Not quite, but that's the beauty of science. It's about exploring the unknown, pushing the boundaries of knowledge, and sometimes even venturing into seemingly impossible realms. And who knows, maybe someday that glass of water will hold the key to a new era of clean energy.
Well, I have to say my mind is officially blown.
Mm-hmm.
We've gone from sound waves to collapsing bubbles to miniature suns, and the potential for clean energy all in a matter of minutes.
And we're just getting started. There's so much more to explore about this fascinating phenomenon. It really is a testament to the power of just like observation. I mean, think about it. For centuries, people must have seen bubbles collapsing
Right.
in their drinks or in streams or in ocean waves.
Sure.
And yet, it wasn't until relatively recently that we started to even like unravel the incredible physics
Yeah.
happening at that microscopic level.
It's like we've been surrounded by this mind-blowing phenomenon all along, but we just needed, like, the right tools and perspectives to, like, truly appreciate it.
Exactly. And it makes you wonder what other seemingly mundane occurrences
Right?
hold such profound secrets. What else are we overlooking?
Yeah, it's almost humbling,
It is.
isn't it, to think about all the hidden complexities that might be operating just beyond our everyday awareness?
Absolutely. And it's that sense of wonder, that drive to uncover the mysteries of the universe that fuels like scientific exploration. Sonoluminescence is just one example of how something that might appear simple at first glance can lead us down this like rabbit hole of incredible discoveries.
Speaking of rabbit holes, one thing that really caught my attention is the sheer range of conditions created within these collapsing bubbles. We've talked about the extreme temperatures,
Right.
but I understand there are also, like, intense pressures and shock waves involved.
Oh, absolutely. In fact, the pressures generated during bubble collapse can be thousands of times greater than atmospheric pressure.
Wow.
That's equivalent to the pressure found deep beneath the ocean's surface.
So it's not just about the heat, it's this whole symphony of, like, extreme forces all converging in this tiny ephemeral space.
Exactly. And those forces have like fascinating implications for the light that's produced. For example, the duration of the light flash is incredibly short,
Okay?
often lasting just a few picoseconds.
Picoseconds.
Trillionths of a second.
So it's not just like a continuous glow, it's more like a rapid-fire series of, like, ultra-fast bursts of light.
Precisely. And the spectrum of that light is also quite intriguing. It tends to be broad, spanning a range of wavelengths, which suggests that the light emitting process is like quite complex
Okay?
and involves like multiple mechanisms.
So it sounds like there's still a lot that we don't fully understand
Oh, yeah.
about the, like, intricate dance of energy occurring within these collapsing bubbles.
Absolutely, there is. And that's what makes it such fertile ground for ongoing research. Scientists are still trying to, piece together
Yeah.
all the factors that contribute to the intensity, the duration, and the spectrum of the light emitted.
It's like a cosmic puzzle waiting to be solved. And you mentioned earlier that there's, like, a bit of controversy surrounding the potential use of sonoluminescence for fusion. Can you elaborate on that a bit?
Sure. The debate largely centers around whether the conditions within these collapsing bubbles are truly extreme enough to overcome the electrostatic repulsion
Okay.
between atomic nuclei, which is essential for fusion to occur.
So even though the temperatures are incredibly high, there's still some question as to whether they're, like, sufficient
Yeah.
to initiate a fusion reaction.
Exactly. Some researchers argue that the temperatures might be high enough, but the duration of those temperatures is simply too short
Gotcha.
for fusion to take place. Others suggest that the pressures and densities within the bubble might not be sufficient.
So it sounds like a delicate balancing act.
It is.
You need just the right combination of temperature, pressure, and density, all occurring for a long enough period of time to, like, trigger fusion.
It is, and to add another layer of complexity, there's also the challenge of scaping up the process. Currently, sonoluminescence experiments
Right.
typically involve like just a single bubble
Right.
at a time. To be practical for energy production, we'd need a way to like create and control millions, if not billions,
Wow.
of these bubbles simultaneously.
That sounds like a pretty daunting task.
It is, but despite the challenges, the allure of fusion energy is so strong that research into sonoluminescence continues.
Right.
After all, even if it doesn't turn out to be the key to like clean energy,
Yeah.
the insights gained from studying this phenomenon could have implications for other fields like material science, medical imaging, and even astrophysics.
Oh, wow. So even if the fusion dream doesn't pan out, the knowledge gained from exploring sonoluminescence could still ripple through, like, various scientific disciplines.
Absolutely, and that's often the case with scientific exploration. Sometimes the most valuable discoveries are the unexpected ones.
Right.
The ones that emerge from, pursuing a seemingly unrelated line of inquiry.
Like every scientific endeavor is a journey into the unknown, with the potential to uncover hidden connections and lead us to unanticipated destinations.
Exactly, and that's what makes science so exciting, the endless possibilities, the constant pursuit of understanding, and the humbling realization that we're just scratching the surface
Yeah.
of what there is to know about the universe.
Yeah, it's just crazy to think about all the, like, potential applications that could come from something as simple as a collapsing bubble.
I know. It speaks to the kind of the interconnectedness of scientific disciplines. Here we are talking about sound waves and fluid dynamics and thermodynamics and nuclear physics. It's a reminder that, like, the universe doesn't really adhere to our neat little categories of knowledge.
No, it doesn't at all. It's like sonoluminescence is a, like, microcosm of the universe itself, containing within it this, like, symphony of forces and principles that we're only just beginning to understand.
Exactly. And that sense of mystery, that drive to, like, unravel the complexities of the natural world, it's what makes science so compelling.
For sure. As we've been talking, I keep coming back to something you said earlier about how sonoluminescence might have implications for astrophysics.
Right.
That just seems like kind of a leap. What's the connection there?
Well, it turns out that the processes occurring within these collapsing bubbles, they might actually share some similarities with phenomena that are observed in stars and other celestial objects.
Oh, wow.
For example, the intense temperatures and pressures generated during bubble collapse could provide, like, insights into the conditions that exist deep within stars where nuclear fusion takes place.
Oh, so by studying these tiny bubbles, we could potentially gain a better understanding of the processes that, like, drive the evolution of stars and galaxies. That's amazing.
It is, and it highlights the power of analogy and, like, cross-disciplinary thinking in science. Sometimes, by studying something small and seemingly insignificant, we can gain insights into something vast and seemingly incomprehensible.
That's really cool. It underscores the idea that the universe is just full of surprises
It
and
is.
that knowledge can emerge from the most unexpected places.
Absolutely, and it's a reminder to always stay curious, to keep asking questions, and to never underestimate the potential of even the simplest things to reveal these, like, profound truths about the nature of reality.
Well said. This deep dive into sonoluminescence has been a really, really eye-opening experience.
Good.
I feel like I've gained a whole new appreciation for the hidden wonders that surround us every day.
Me too. I hope it sparked a sense of wonder and curiosity in you as well.
Oh, absolutely, and I'm sure our listeners feel the same way. So to kind of wrap things up, what's the one key takeaway you'd like to leave our listeners with?
I think it would be this. Never underestimate the power of observation and curiosity. The next time you see bubbles collapsing in a glass of water, or hear the crackling of a fire, or witness, any seemingly mundane phenomenon, just take a moment to pause and consider the incredible complexities that might be at play. You never know what scientific mysteries you might unravel just by paying attention to the world around you.
Perfectly said. And on that note, we're going to bring this deep dive into sonoluminescence to a close. Thank you for joining us on this journey of exploration, and as always, keep those curious minds engaged. 2-2 time.